Okay, we're going to start by looking at a couple of questions that we haven't been able to address in the last couple of days. More like common sense questions, but they don't sort of fall into the titles that we had before. So they're just questions that are, now that we know what these equations lines look like, we can ask a couple of questions like this one. Is the point 2, negative 3, 9 a point on the line that's given there? So I know that if I wanted to find a particular point on this line, I know that 4, 1, negative 3 is a point. That's the point when t equals 0, and then nothing else is there. I also know if t equals 1, if this was a 1, then I could get another point by going 4 plus 1, 1 plus 2, 3 plus negative 3, and I know that the point 5, 3, 0 is on the line. So I can get lots of points, and I can keep changing values for t and so forth and get all sorts of points, but whether this point is one of them on the line is a little bit more tricky. 0.2, negative 3, 9. So I'm going to talk about how to do that. So for starters, I always find it easier to take these questions and put them in parametric. Parametric is my favorite version of the line. So I can see there's the x equals 4 plus t, 1t. Then y equals 1 plus 2t. I came from there, there, and there. And then the z comes from this equals 3 plus or minus negative 3t. So 3 minus 3t. This way I can examine the x component, the y component, and the z component and try and figure out if indeed the point that I have is on the line. So what I'm going to do is I'm going to assume it's on the line. So remember, in order to be on the line, it must satisfy this equation, which means there must exist some t. We know it's not 1, we know it's not 0, but it could be a 3 or a 4, or it could even be a fraction. This is why it sometimes gets difficult. There might be some t that will spit out a 2, negative 3, 9. So I want to know if there is. So I'm going to assume that there is. And if it is, that means that the 2 would represent the x. The 2 would be the x. The negative 3 would be your y. And your 9 would be your z. So let's examine each of them. So let's examine the x part here. So that would mean it would be 2 would equal 4 plus t. So if I rearrange this, I would get that t is negative 2. So negative 2 is the value for t that I need to get the first thing, the x, the 2. Now, I'm going to go off and test the other ones. So I'm going to try the y. So I'm going to put in negative 3 equals 1 plus 2t for the y part. Again, isolate. And I'm getting negative 2 again. So this is good. That means that there is the chance that there's a single t that's going to spit out my coordinates, because I found that the t is the same to get the x component and the y component. Now I'm going to test the z. And if the z is also getting me a negative 2, then there is one single value of the t that satisfies this, and it is on the line. If the value for t is different, then there isn't a value for t that's going to, a single value for t that will get me these three numbers. Let's do a test. So now we're going to try 9, and we'll put it into the z. So 9 minus 3 is 6. And lo and behold, it does work. And since we have the same t, then the point must be on the line. So it's a quick little test to see if a point's on the line. we go off and substitute that point into the line to see if we get the same p-value or k-value or s-value, whatever that constant is in the equation. Understanding that if we get different answers, that means it was impossible to pick a single value for t that would go here, here, and here that would spit out the given point that we're looking at. But in our particular example, it is. If you plug in -2 into this equation, or even right here in -2, you're going to spit out 2, -3, 9. So that's how we go off and find out if a point is on a given line.